Okay, here are some more. Module 5, some of the calculations you can expect to see in this module, which now has completely tied in time value of money and gradients. Different types of gradients for the changes of the money. All right, first problem. Let's just say we got an aerospace contractor with 4 employees, combined salaries through the end of the year, $250K. Expects an average raise of 5% per year. That would be nice. Calculate present worth of the employee salaries over the next 5 years with an interest rate of 12%. Well, one way you could do this, simply put in, okay, at the end of the year, year 1, salary is $250,000. And the shifted back 1 year on that one would just be the present value shifted back by 1 year. And you can do that for the 5 years and then sum those up and you can actually get that. And all you have to do is simply increase the salary by 5% per year. Notice something here. If you start at $250 and you increase by 5% per year, by year 5, you're already up to $300,000 a year. Of course, that's 4 employees, so it's divided by 4, but still not so shabby. Well, that's one way to go about it, and that will get you there. See what I did there? Took the initial salary, increased it by 5% every single year, then took the present value based on the year that it was and summed those up for the 5 years. Or P over A, G, I, and N. There is an actual equation for that. That is, by the way, in your modules. I've given you all the equations in your modules. But you start with 250,000. That equation, if you look up here, it's a pretty significant equation. I think what I'll do here, just for jollies, is probably take that B14. Well, let's just take that B14 times out of there so you can see what the factor is. So the factor is 3.94. Let's make that an actual number. Format cells, number, decimal places, go up. Let's go 7 or 8 is fine. And then you can just say equals that times that, and it's the same number. 985,012. There we go. Not a problem there. All right. Let's try another one. Linda made a deposit of $400 in her savings account 5 years ago. The account was earning 6%. No more deposits. In the second year, the interest went up to 8%. Good deal. She didn't make any more deposits, though. However, she, in year 3, which is the end of year 2, deposited an amount, okay, and then the interest rate increased up to 11%. Nice. Which made Linda deposit double the amount of money that she had deposited in year 3 and year 4. Hey, that's a smart move there. And at the end of year 5, she had this amount of money. Now, question was, what was C? Well, that's going to get you down into the what ifs. Good old what if, and that's a goal seek. Now, this is the equation here. This is what we know she's got, and this is the goal that we're seeking, and then this is 2 times the goal that we're seeking, but we're going to seek this goal. Now, if you set this up so that each of these, okay, has, okay, the amount of money here. So the 400 at 600% interest is going to have 424 at the end. Now, that 424 is going to be at 8% interest, which is going to give you this. Which is going to be at 11% interest, which is going to give you this. But you have to add this to the percentage to get this. So it's a sum of 2 things. Both of which are going to earn interest. That plus that at that interest rate will give you this. Okay? That plus that. So this number here plus this number here at this interest rate will give you this. Now, can we do this with a what if? Well, if we set this number up to be a target cell, and this to be 2 times the target cell. And if we take that target cell and set it to 0, everything's going to drop back down. However, if we go to a what if and goal seek, we're going to set this cell, or actually we want that cell to be, we want this cell to be equal to 3074.39. How much money she's going to have at the end by changing this cell. And voila, it finds that great number of $700. And that's it. Actually, probably is exactly the same question I'll probably give to you, even with those numbers, because they work out so nicely. But you do need to prove that you can do a goal seek. So there's that. And you do, by the way, need to know how to do a goal seek. Yeah, can you copy and paste and make it look like you didn't do it? Sure you can. And then you'll regret it dramatically later. You'll want to know how to do this. All right. Here's a fun one. Find the present worth of a bunch of unequal payments. Well, this one is pretty much simple. Now, I got totally different numbers in here because I was playing around with it. So 40123. Okay, that's year 1. Year 2, 20123. Poof. Year 3 is 30,000. Year 4 is, 25,000. So let's go 25123. Whoosh. And year 5 is 50,000. 50123. By the way, if your numbers here don't fit, just double click up on that line and voila, they'll fit. And there's your number for that, for those specific there. Oh, by the way, the interest rate was not, it was 6.6%. Let me change that to 9, and that just changes everything. What did I do there? I took the present worth of each of these. 1 plus I to the n, 1 plus I to the n, and this is the number you multiply that times. Okay? So you divide each of these just to get them into present worth terms. Okay? Because I think we're actually trying to find the present worth, not the future worth. So find the present worth of all those payments, which is divided by 1 plus I to the n. That's it. There's your I. There's the amount that's going to get that. And you just sum all those up, and there's your number. That wasn't too hard. Let's go for another more challenging problem here. All right, a chemical company determined that a need for a chemical additive will improve their product by 20%. CEO arranged to purchase the additive. This is a normal fixed cost contract. Okay, 5-year contract at $7,000 per year. Starting at year 1, he expects the annual price to increase by 12% per year in the 6th year through 13. Yeah, you negotiated a fixed price for a specific period of time. That, by the way, is relatively common. Okay, at the end of the period of time, the company that is selling you the stuff is allowed to change the price. Let's see. Now, that starts in the 6th year through year 13. Additionally, an investment of $35,000 was made to prepare a site suitable, so you've got another payment that's at year 0. So you want the total present worth of all of those cash flows. So pretty much everything in that case is going out. And you got a gradient. So, but that gradient doesn't start. So you're going to see an annual price increase. You're getting hit by 12% a year starting in year 6. Woof. So you can see, here's my payments. Years 1 through 5. Beautifully, 7,000 with an initial payment at time 0 of 35,000. At year 6, you're going to start seeing those numbers jump up by 12% a year, and just keep going up through year 13. How do you get the present value of that? Well, you just take those suckers and add them all together. What's another way you could do it? Well, one way you could do it is you could say, okay, let's first get the value of all those payments before the gradient starts. That's year 5. Then at year 4, you're going to start the gradient payment, and the gradient payment is going to be at a G of 5%, which has an equation that you can do. It's that big old long equation right there, or geometric gradient series. There you go, right there. There's your equation right there. Woof, woof, woof. Easy. Okay, you just plug that baby in there, and that's going to give you the value of the gradient. So I did the series as 1. the gradient as another, but then that gradient didn't start until year 4, so I have to take that gradient and I have to make it at year 0. So I have to slide it back, which is divide by 1 plus I to the 4 to bring it to the present value. So I basically calculated this, then the gradient that started at year 4, slid the gradient back to year 0, added these two numbers, the annual series, and then the gradient together, and I got, oh, looky there, it's the same exact value I got by calculating each individual year. What a surprise. Kind of what I expected to have happen there. Oh, look at this one. Here's an exciting one, a payment every 2 years. So you borrow 24 grand, 5 equal payments over 10 years, every 2 years, 8% interest compounded annually. So the compounding is not every 2 years. What is the amount of the equal payment that you have to pay every year? Well, I could just say, set up a table here, which has 24,000. Okay, I have to figure out what that payment is. So I'm going to try to get that present value of all these guys summed together, which would be payment year 2, payment year 4, payment year 6, payment year 8, payment year 10. Notice, each of those, I can get the present value of each of those payments. Funny thing is I don't know what that payment is. It's going to be whatever this value over here is, but if I make that value 0, oh no, we don't know what it is going to be anymore. However, we can do a what if. Let's seek. Let's set the cell, this cell, which is the sum of all of them. Okay, I'm pretty sure that was the sum. Pretty sure I summed them. Let's cancel for a second. Did I sum those? Yeah, see, I summed all those together. So let's do this. Let's goal seek and set the sum of all those payments equal to 24,000, because that's the present worth there, by changing this cell right here. And what do you know? There's the payment. What else could I do? Well, I could calculate the effective interest rate, which is a way to do this. 1 plus the interest rate divided by 1 is 1. Up arrow 2, period, minus 1. So the effective interest rate is 16.64. Okay, that should make a little bit of sense. The interest rate is 8. That's per year. So the effective interest rate is the effective interest rate for period every 2 years. But it's not going to be exactly 16 because that first year has as a period, there's actually more interest involved there. Interesting problem, isn't it? So then I just use my A over P with an effective interest rate, a number of periods, not number of years, number of periods, which is every 2 years, and a payment, a value of 24K. And guess what? Which gives me 24 times this, which gives me, it's magic. Again, the same exact answer I got up here. Now, you saw that I solved most of these problems multiple ways. Guess what? It doesn't matter how you solve them. What matters is you understand how to shift money in time. And then I added something new to this guy here. I had payment periods, and I had to calculate a new thing. There's a new thing here. Effective interest rate. The interest rate that you would see if this was actually every 2 years. Pretty amazing stuff. And it should make sense. Wonderful, wonderful. I'm hoping that you really did get something out of those calculations there. Read through those problems. They're going to look really, really familiar to you. If you don't catch this on the first go-around, I am a pleasure to listen to over and over again with my soft, soothing voice. You should enjoy just going through these lectures over and over again, but these calculation lectures, they're wonderful. That's it. On out. Have a good day.